Hello. In this video, we are going to discuss one of the problem from Physics NET 2020 exam, which is on double slit interference. Code for the question is 178. Okay. So the figure shows intensity of interference pattern in Young's double slit experiment with two slits of equal width observed on a distance. If the separation between the slit is doubled and width of each slit is half, the new interference pattern is best represented. So, if we look at the pattern, so look at this envelope, you can see the whole peak. Okay, that's a single slit diffraction, and inside that single slit diffraction envelope, what we have is the double slit interference pattern. So, if we increase separation between the two slits, then the double slit interference fringes will start coming close to each other. Remember, one of the conditions for distinct interference pattern is that the two slits should be as close as possible. Okay? But in this case, they are saying that the distance separation between the slit is double. So the fringes will become thinner. And in case of single slit diffraction pattern, if you reduce width of the slit, then the central maximum will start spreading. So what we are given is that the separation between the two slit is doubled, increased. The individual fringes will become thinner, and the width of each slit is half, which means your central envelope will actually broaden. That's what is expected. Okay, so let's see what are the options given. That's the interference pattern given, and these are the four options given to you. And if you look at it, in the first case, the individual fringes have become narrower, but the central maximum also remains of the same width. Okay. In fourth case, if you see, the central maximum has broadened, but the individual fringes also have broadened. Whereas in case of number 3, the central maximum is much reduced in size, although the interference fringes have broadened. And if you look at the second one, the central maximum has broadened and individual fringes have become thinner. All right. So this is what we expected. That is what is going to be the likely choice. Let's review it once again. Okay. So if A is the slit separation, then the condition for maximum of interference is A sine theta equal to n lambda. So if you are increasing A, okay, which is a slit separation, then theta will become smaller. That means your individual maximum will become thinner. Whereas in case of single slit diffraction, if your slit width is B, then the diffraction maximum, first diffraction minimum will come at B sine theta equal to lambda, m is equal to 1. Right? So in this case, if you reduce B, your theta will be larger. So the central maximum will be widely spread. So A is doubled, B is half, width of the interference becomes narrower, and width of the central diffraction maximum. And that condition is met very well by the pattern. So our answer is very much. For more of the study material and such videos, you may want to visit our website as well as our YouTube channel. Thank you very much.